Year 1903. An ordinary day in the life of a digger, until he stumbled upon a human skull that was almost completely out of the ground. That skull seemed too old to be there. Archaeologists rushed over when they heard the news, excited, of course. When they arrived, they realized that was the most complete skeleton ever found on British soil. They quickly started calling the skeleton the Cheddar Man. Later on, they discovered he was a hunter-gatherer who had lived at least 10,000 years ago. One of the most feared professions of the time, mainly because that was the Ice Age, and the skeleton belonged to an ancestral Englishman. Time passed, and the discovery just sat there, untouched, for more than a century, to be exact. Nobody was interested in it anymore. Until someone wondered what that Englishman might have looked like. Would he look similar to us today? The question was good enough that the Natural History Museum in London extracted DNA from his tooth and began a forensic investigation to predict physical traits from the genome. And the result was truly surprising, so much so that it made headlines worldwide. The reason? The man, nicknamed Cheddar Man, had blue eyes, dark hair, and dark skin, classified in one of the darkest pigmentations on the scale used by the researchers. A 10,000-year-old Englishman had dark skin and blue eyes, a combination that barely exists anywhere else in the world today. And he wasn't an exception.
Other skeletons from the same period later turned up in other European countries, Spain, Hungary, Luxembourg, and the DNA of all of them told the same story. European hunter-gatherers, living where the heart of white Europe is today, still didn't have the genes that give modern Europeans their light skin. Europe, which most people imagine as having always been white, only truly became white in the last 6,000 years. That might sound like a lot, but on an evolutionary scale, it's a ridiculously small fraction of our species' history. How did humanity go from a single skin color to the entire palette that exists today? That's what you're about to understand. Before moving on, just a reminder that this is still a small channel, and I need your help with a like and a subscription. It's free, and it helps me a lot. To understand how all this happened, we need to go back much further than Cheddar Man. The first thing science has nailed down, beyond any doubt, is the starting point of our species. About 300,000 years ago, when the first Homo sapiens appeared in Africa, everyone had dark skin. Not most people, not almost everyone. Everyone. Light skin didn't exist anywhere on the planet at that time. It was one species, one skin tone, one continent. All the diversity that exists in the world today is more recent than that. The oldest fossils of our species were found at a site called Jebel Irhoud in Morocco. They were more than 315,000 years old.
They don't preserve skin, of course. That's impossible. Fossils keep bone and teeth, not pigment. But biology, Africa's ecology, and the genetics of living populations all converge on the same answer. Those first humans, living under an equatorial sun blazing overhead, had a lot of melanin. It was the only way to survive in that place. And to understand why, we need to understand what melanin does. Melanin is the dark pigment the skin produces, and its job is to protect the body from ultraviolet radiation. That radiation is invisible, but it's not harmless. It comes from the sun in constant waves, hits the body, and when it enters cells, it causes damage. It breaks chemical bonds, damages DNA, and when that damage builds up in the wrong place over the years, it turns into skin cancer. Melanoma, one of the most aggressive types there is. Dark skin, full of melanin, is a kind of built-in sunscreen. It blocks part of that radiation before it reaches the DNA in deeper cells. Whoever had more melanin lived longer, and whoever lived longer had more children. Natural selection did its work silently over thousands of generations. But skin cancer wasn't the only reason, and it may not even have been the main one. There's another thing ultraviolet radiation does to the body that very few people know. It destroys folate. Folate is a B-complex vitamin, essential for making new cells and absolutely critical during pregnancy.
It's folate that protects the developing baby's neural tube, the structure that will become the brain and spine. When a mother's folate drops during pregnancy, the risk of the baby being born with serious defects rises sharply. Spina bifida, anencephaly, malformations that kill before birth or shortly after. Think about what that meant in practice. A light-skinned pregnant woman, exposed to intense equatorial sun, had her folate destroyed by radiation before it could reach the baby. The children were born with problems, didn't survive. And that woman's genes didn't get passed on. Generation after generation, this brutal filter kept favoring those with more melanin. Because dark skin protected folate, and folate protected the baby. For hundreds of thousands of years in Africa, dark skin wasn't an aesthetic or cultural choice. It was survival. It was what separated a pregnancy that succeeded from one that ended in silent grief. And that's roughly how humans lived for a long time, looking similar to one another, under the same sun. Until they began leaving Africa. This is the moment when the story of skin color really gets complicated. The exit from Africa wasn't a single event. It was a long process. It didn't happen all at once, nor along just one route. There were waves, comings and goings over tens of thousands of years. Groups pushed north and east, crossing Arabia, reaching Eurasia, spreading across the planet. Some turned back, others vanished along the way.
And as they moved to higher latitudes, something started to change in the environment around them. The sun. The farther from the equator, the weaker the ultraviolet radiation that reaches the ground. In the northern European winter, the sun sits so low on the horizon that UV radiation barely makes it through the atmosphere. And that's when the game completely flipped. It was no longer excess UV that was killing people. It was the lack of it. To understand the problem, another piece enters the story. Vitamin D. Human beings need a certain dose of sun to produce vitamin D in the skin. Vitamin D is what ensures calcium absorption, strengthens bones, and regulates the immune system. Without it, bones weaken, the immune system collapses, children don't grow properly. Rickets, repeated infections, death in childhood, it was a serious problem. The irony of evolution was this. Dark skin, which was great near the equator, became a serious problem in the frozen north. It blocked so much radiation that the little sunlight that did get through wasn't even enough to produce a decent amount of vitamin D. Those with slightly lighter skin at those latitudes captured the weak northern sunlight better and produced more vitamin D. Stronger, healthier children, more likely to reach adulthood and have children of their own. And those genes kept getting passed on. Notice that light skin, then, isn't evolution in the sense of improvement. It's not more advanced or more modern. It's just a local adaptation to a specific condition, little sunlight. Put that same skin back at the equator, and it becomes a disadvantage right away. Skin color isn't a hierarchy. It's an address. It tells you where a person's ancestors lived long enough for the environment to leave a mark on their DNA. Nothing more. Even after humans reached Europe, they remained dark-skinned for tens of thousands of years. The change didn't happen as soon as they set foot on European soil. It took a long time. In Spain, in a cave called La Branya, they found the skeleton of a man from 7,000 years ago. In 2014, the journal Nature published the sequencing of his DNA, and the conclusion was the same as Cheddar Man's, dark skin and blue eyes. A European hunter-gatherer living in what is now Spain, still carrying the African pigmentation of his ancestors. The genes that give modern Europeans their light skin simply hadn't arrived there yet. Blue eyes? Yes. Light skin? No. Light eyes came before light skin. And that combination almost nobody sees today. Dark skin with blue eyes was the norm in Europe for millennia. Stop and think about that for a second. It really is strange. The standard image of a European that movies and history books sell is a snapshot from about 6,000 years ago. Everything before that looked different. So what changed? Why did Europe become today's Europe? The turning point came through a specific migration at a specific moment.
Around 9,000 years ago, farmers who lived in what is now Turkey and the Middle East began spreading across Europe, bringing with them a revolutionary novelty for the time, agriculture. They planted wheat, raised sheep, stayed put in one place, a completely different life from the hunter-gatherers who already lived there. And they carried in their DNA a variant of a gene called SLC24A5, which the European hunter-gatherers simply didn't have. That variant reduces melanin production. Result?
lighter skin. As these farmers entered Europe and mixed with the locals, that variant spread along with them, fast in some regions, slow in others. Ancient DNA data show that the light skin variant of SLC24A5 spread across Central and Southern Europe starting around 8,000 years ago. A second variant in another gene called SLC45A2 only swept across the continent starting about 5,800 years ago. In other words, the light skin we associate with Europe wasn't there from the start, and it didn't arrive all at once either. It came with farmers from the Middle East, crossed the continent, and gradually overtook the local dark skin, generation by generation. Many Europeans remained dark-skinned well into the Bronze Age. The picture of a white Europe is, on an evolutionary scale, recent. Very recent. And there's more. Researchers raise an interesting hypothesis about why this change was so fast once it started.
European hunter-gatherers ate a lot of meat, fish, liver, food rich in vitamin D. When those groups became farmers, their diet changed. More grain, less meat, less liver. The dietary source of vitamin D dropped, and that increased the pressure to produce vitamin D through the skin even more. With a diet deficient in vitamin D, having light skin became an even bigger advantage at those northern latitudes. It's possible that agriculture itself, by changing Europeans' diet, sped up the whitening of Europe. Changing the food changed the skin color of an entire continent. It's not something they teach in school. And while all this was happening in Europe, something similar was happening on the other side of the world, but through a completely different genetic path. East Asian populations also developed lighter skin tones than African populations, but the main gene behind Asian light skin isn't SLC24A5. It's a different one, called MFSD12, in specific variants. Two groups of humans living at similar latitudes, arriving at similar skin tones, but by distinct genetic routes. That has a name in biology, convergent evolution. The same solution to the same problem invented independently twice by nature. Skin color isn't a single trait that appeared once and spread across the world. It appeared multiple times in separate populations, each one tweaking different pieces of the same set of genes. There's even a case that breaks any simple equation like far from the equator, light skin. The Inuit, a people living in the Arctic in Alaska, northern Canada, and Greenland, are among the populations living farthest from the equator on the entire planet. By the plain logic of latitude, they should have some of the lightest skin in the world, but they don't. The Inuit have medium to dark skin tone, much darker than Scandinavians living at similar latitudes. The reason is food. The Inuit eat oily fish, seal, whale, marine animal liver in enormous quantities. It's a diet with so much natural vitamin D that they simply never depended on their skin to produce that vitamin. Selection for light skin, in their case, wasn't strong because the vitamin D problem was already solved on their plate. Their skin stayed at the tone it was because diet covered what skin would have covered in other groups. It's living proof that skin color isn't just about latitude. It's latitude plus diet plus culture plus migration plus time. Several factors at once. And here's a moment worth pausing on, because this is the part that bothers a lot of people most when it comes up. For centuries, the idea that fixed biological human races exist was used to justify horrific things. Slavery, colonization, genocide, segregation. These were crimes based on the idea that skin color divided humanity into internally different groups, biologically different, with different capabilities.
Modern science, by mapping the genes behind skin color, dismantles that idea in a way that can't be refuted. Skin color is what's called in genetics a polygenic trait. That means it's controlled by more than 100 different genes, each contributing a little bit to the final result. And skin color genes don't travel together as a fixed package. There's no such thing as a white race gene set or a black race gene set. The variants that affect skin tone are distributed in complex ways around the world and don't follow the racial categories society invented. In 2017, a study published in the journal Science, led by geneticist Sarah Tishkoff, analyzed African populations and found something that changed the game. Many of the genes associated with light and dark skin date back 300,000 years. In other words, they predate Homo sapiens itself as a species. Alleles that are seen today as European are also present in African populations, sometimes at high frequency. And within the African continent, skin color variation is the greatest in the world. There are Africans with very dark skin, Africans with much lighter skin, and every shade in between. The greatest diversity of human pigmentation is found within Africa, not between Africa and the rest of the planet. That means the category of race as a fixed biological block simply doesn't show up in the DNA.
What shows up is a continuous palette of local adaptations produced by hundreds of thousands of years of migration, mixing, and natural selection. A palette that keeps changing to this day because humans keep mixing, traveling, having children with people from other places. And the children of the children of the children will have genetic combinations no one can predict. So come back with me to that cave in England. Cheddar Man, unearthed in 1903, sat in a museum for more than a century while everyone assumed he looked like a present-day Englishman. In 2018, his DNA undid that assumption in a single test. Dark skin, blue eyes, an ancestral Englishman who, if he showed up on the streets of London today, nobody would recognize as English. The story of humanity's different skin colors isn't a ladder climbing from dark to light, from primitive to civilized, from there to here. It's a web of migrations, mixing, pressures from the sun and from food, and genetic accidents that over hundreds of thousands of years produced the palette found on any face today. Everyone with light skin, anywhere on the planet, descends from dark-skinned people. It's not a metaphor, it's not poetry, it's genetic fact. The genes that give light skin arose within populations that had already existed for a long time, carrying older versions of the same genes. And that specific tone of your hand, whatever it may be, doesn't place you in any fixed category. What it does tell you is which part of the planet your ancestors lived in long enough for the sun and food to leave a mark on their DNA. It's a record of address, not of identity. And that address has changed far more times than any history book usually tells. If even skin, that thing that seems so definitive, so innate, so that's just how I am, is just an adaptation that changed several times throughout human history, what else do we think is fixed that's actually just a phase? Think about it. Subscribe to this channel and let's learn more about the origins of life and habits, normal or not, that we have.